Hello everyone, thank you for joining me for my talk about our company Veyron and our smart idler technology. Veyron is essentially an Internet of Things based hardware and data analysis technology service provider. We provide condition monitoring systems for critical bulk handling machines. These are the important conveyors used on your operation where the productivity and efficiency of this machine is critical to the production of your operation. Our technology is risk mitigation and uptime assurance technology. On any one of these very important conveyors, there are thousands of points of potential failure. These rotating components are usually difficult to monitor and maintain adequately to a point where the availability of the equipment is at a very high level and downtime is minimized. We see that the failure of these rotating components usually accounts for the leading cause on why this critical conveyor is down and off production or has a breakdown. And it is also globally and statistically the #1 reason for the ignition of fires. So our technology has a core value proposition of eliminating conveyor idler related downtime. This is a significant contributor to lost productivity on these critical conveyor systems. It extends to simplifying maintenance. By simplifying maintenance, this means that you are using your resources and your personnel in a more optimized manner to change less conveyor roller components and do this in a more targeted approach. So you know exactly which conveyor roller component needs to be changed before it actually fails so that you can correctly plan for the maintenance of this component. It improves safety of personnel because the reduction in exposure to the hazard for your personnel is something that can be quantified. You have less people around your rotating components for a shorter period of time. Not only this, but because you are targeting your maintenance and changing less conveyor rollers, it means that your exposure to manual handling is reduced. So we all know that on any given major bulk materials handling operation, there is a lot of time spent changing conveyor rollers. And this is all hazard exposure to manual handling risk. And you can get back sprains and strains and hand injuries that occur. And we keep track of mines inspectorate databases where we see this as being a regular injury root cause. We optimize spares and inventory management because we know exactly what the consumption of the conveyor rollers is forecast to be on the operation using our smart technology. And this means that the operation does not have to keep as much money in working capital locked in spares and inventory on site. We can adopt a just-in-time type approach to the delivery of these spare components for when you need them and you know you're going to be changing these components. And like I said, we prevent catastrophic fire incidents. So there is an actual cost of carrying the risk, the unmitigated risk of a fire on your conveyor system. And this might be a 1 in 50 year or a 1 in 100 year event, a catastrophic event that will cost your operation multiple millions of dollars if it happens. And we all think it may not happen, but it actually does, and it happens frequently around the world. And this might only be a 1 in 50 year risk, but when it does happen, the cost of that incident is very, very high. But when you annualize the cost of this risk, the annual cost of the risk of a catastrophic fire is actually quite high, and our technology mitigates this to zero. So people, in summary, use our technology to reduce their personnel exposure to hazards, rotating equipment and manual handling injuries. We mitigate the risk of very high impact but low frequency events. These are catastrophic events that don't happen very often on any site, but when they do happen, they are high impact and high cost. We optimize inspection crews and resources, so allowing you to save, make efficiency gains around how you use your personnel on their maintenance tasks. And we provide you confidence in your equipment performance, such as belt weighers and other critical conveyors like ship loaders and stockyard material handling equipment. So to give you an example of a problem, you might have a certain conveyor in your process stream that's difficult to inspect. Either access is constrained, it might be at a high location, personnel do not enjoy traveling to that part of the conveyor to inspect the components, and therefore they neglect the work there. Or it could be in a very, very dusty and space confined environment that's very unpleasant to be in and dangerous to be in. So this means that the current process for managing the rotating equipment and the rollers in these locations is left to people. And when people don't enjoy being in an environment, it means that their inspections become irregular. I've already mentioned that they're difficult, but it's also risky because people usually it's human nature to take shortcuts in these kind of harsh environments. So this means that your exposure to the potential catastrophic failure increases in these locations. I'll provide you some examples now of where these failure incidents have created a catastrophic 1 in 50 or 1 in 100 year event for the operations that are using conveyors. This is an example, and you can do your own research of a fire in Brazil, in one of Vale's ports. This cost Vale 32 million tons of iron ore at a time when the price was roughly $150 per ton. So we're talking an almost $500 million financial impact to Vale for this fire that occurred on a ship loader because a single conveyor roller failed. This would be considered a 1 in 50 or 1 in 100 year event. So if it's a 1 in 100 year event, $500 million carried across the 100 years is $5 million in annualized carrying cost of that risk. That's a $5 million per annum problem for Vale across 100 years if left unmitigated. Newmont Gold Corp, their Musselwhite mine in Canada, had a catastrophic fire because a conveyor roller failed on the conveyor system. This shut their mine for an extended period of time, over 12 months, I believe. This is no production from an entire mine for over 12 months because of a catastrophic fire in the underground environment. And this is not a flammable material. This is gold ore. So fires do occur in commodities that aren't necessarily considered explosive or flammable. And these fires, as I said, are statistically caused predominantly by the failure of conveyor components such as conveyor rollers. Iron ore company in Canada, they have a port in Quebec. 2 bucket wheel reclaimers load ships, so they have 2 ship loading berths, and each ship loader and bucket wheel reclaimer accounts for 50% of the port capacity. A failing conveyor roller on their 1 bucket wheel reclaimer created a fire that shut that bucket wheel reclaimer, and therefore meant that that loading stream could not complete the loading of a ship. At the same time, the other reclaimer was down for maintenance. So the port lost 100% of its loading capacity for an extended period of time because of a failure of a conveyor roller component on the bucket wheel reclaimer at the port. Now, just another perspective of where failing conveyor rollers create problems for their operators. Now, these are less catastrophic, but the financial impact can be just as large if left unattended to. This is the failure of items like belt weightometers or weigh stations on your conveyor system. When these are highly calibrated pieces of equipment, and when a conveyor roller in the weigh station begins to fail, it introduces vibration, belt mistracking problems, and additional, like the roller can seize, for example. And this means that the belt is rubbing over a stationary roller, and this introduces error for the calibration of the belt weightometer. So if you're in an operation where it is very important to understand what material you are delivering to your customers over your conveyor systems, and you have as little as 0.5% error introduced into the calibration of your belt weightometer, and this is left unattended for extended periods of time, the accumulation of error in your knowledge of what you have delivered to your customers can be very, very large. In some examples, this data is used to update stock exchanges like the New York Stock Exchange. A gold mining company needs to report its financial figures and its production rates. If the production rates have error in them, and this is erroneously reported to the New York Stock Exchange, this is share price affecting stuff. And so therefore, knowing about when a conveyor roller is going to fail, not has failed, but will fail, knowing about this incident ahead of time in your belt weighers is hugely valuable. So belt weigh stations, as I mentioned, look very much like this. They come in different configurations. There is not many rollers, and the cost of our solution implemented in one of these locations for the peace of mind that it gives you is very, very attractive return on investment. So this is what our solution looks like. It is a series of sensors embedded inside conveyor rollers that monitor the physical condition of the conveyor roller and report its impending failure remotely and wirelessly back to base. This information is sent via the Veyron gateway and can be networked via various different methodologies to your enterprise resource planning software, or your data historian, or your SCADA network. So we can report via the cloud, we can report via Ethernet connection and a hard line to your Pi historian, and we can report via your SCADA. So we support a variety of networking methods to bring the information to the place that you need it. These sensors are roller agnostic. So we will work with many different conveyor roller manufacturing companies within the global industry. We do have premium partners, and in your part of the world, we have a premium partner in the very large conveyor component manufacturer, Precision Pulley and Idler, PPI. We also have premium partnerships with a number of other brands spread through North and South America, and then Australia as well. This is 24/7 monitoring technology that is holistic. It monitors every failure mode. We monitor bearing temperature, RPM, we conduct real-time vibration analysis to determine defects in the bearings, and we also can monitor for the wear of the mantle or the shell. So this wear can be trended so that we can provide an alert when the shell reaches a critical level of degradation. Alternatively, we can also report on carryback buildup. This is the accumulation of material on the outside of the roller. All of these things contribute to early roller failure and contribute to excessive roller usage. Our knowledge is that the global industry changes out far too many conveyor rollers every year, and our technology aims to optimize how people use their conveyor rollers so that they can treat them more like an asset and less like a consumable. So our technology's radio network is a polling scheme. The gateway is the master of the system, and the sensors which are contained inside of the rollers are the slaves. The gateway requests the information individually from every single roller, and this roller will pass its information back to the gateway, and this occurs via a radio mesh network. So the components to our smart idler system consist of 4 individual discrete elements. We have the smart idler sensor. This is the sensor which is embedded inside the conveyor roller. It is a maintenance-free sensor. There is no batteries. It harvests its energy from the rotation of the conveyor roller, and it is built inside the roller when the roller is manufactured by the roller supplier. It is a subcomponent for this conveyor roller and is designed to be just as important to the roller as the bearings that it is monitoring. The next component is our field communication gateway. This is, as I explained to you, the master of the system and aggregates all the information from the rollers, and then we use the gateway to network into your mine system. We can report to the cloud via our Amazon web server, or we can report off the cloud directly on premises with no internet via Ethernet connection to a networking switch, and the data can be ingested into a Pi Historian or a SCADA network. We have our field commissioning scanner, which is what is used to scan the smart rollers into a conveyor when you install them. And then we have our server and application, which can be hosted on premises or in the cloud. So this is essentially the components of the sensor. The stator is mounted on the shaft of the conveyor roller. The rotor is mounted in the bearing housing, and the rotor will spin or rotate around the stator and allow the stator to harvest its energy. And the antenna cap is used to protect the externally mounted antenna from any damage or abrasion from foreign material. The gateway is ruggedized, IP rated, and can be deployed along the conveyor via a mounting bracket. It is very low profile and not a very large piece of equipment. The field commissioning scanner is what we use to scan the barcodes that are attached to all the rollers. These barcodes are attached to the roller by the roller manufacturing company. We use the unique barcode ID to establish the network and allow the conveyor operator to know where a roller alert is coming from to the exact roller. Our software, cloud-based software, is you log in via a user account and you access a summary of your site and what rollers are connected to how many gateways. Are there any alerts? You can look at if the alerts are there, what is the spread between high, medium, and low criticality, and you can investigate what that alert was caused by. You can see a summary along your conveyor of your temperature profile, looking for anomalous temperature peaks to identify potential zones of problem, and vibration profile along your conveyor. You see a list of all the rollers installed on your conveyor, and you can investigate their reporting status of the roller and when the last data was received from this roller. And you can actually go inside the roller and see what both bearings are doing with their temperature in real time, the RPM, and you can also see the vibration analysis information. This is the prediction. This allows us to find a defect emerging within the bearings of the roller up to 6 months in advance before the roller has a failure, a catastrophic failure. You can see the bearing temperature profile of both the bearings, and this is a day-night fluctuation, so you can see hotter temperatures in the day and lower temperatures in the night. And as I said before, earlier in my presentation, talking about the accumulation of error, you can see a chart about the RPM of this roller. And these downward spikes that you see, these are where the belt has left contact with the roller and is skipping, and the roller has slowed down and then sped back up when the roller has come back into contact with the belt. This skipping is error in a belt weightometer system. So you can roll this technology out across your critical conveyors as shown in this list, or any other conveyors that you deem as bottlenecks or very important to your operation. So I'll take you quickly through a case study to wrap up my presentation. We have a customer in Australia who is a gold mining customer. They had a ore processing facility with a shuttle conveyor. This is a moving conveyor that cannot be inspected whilst in operation. And they experience on average 8.2 hours of downtime on this equipment every year because a roller fails and they need to stop the production processes, stop the ore processing facility and all the upstream and downstream processes. This creates downtime, and this downtime costs them roughly $1.3 million every year. They spend almost $48,000 or $50,000 on labor to change rollers and to manage the rollers on this piece of equipment every year. And the volume of rollers is actually only very, very small, only 123 rollers. But these 123 rollers are causing a $1.3 million problem. The annualized cost of carrying the unmitigated catastrophic risk of a 1 in 20 year event for them is $1 million. So a 1 in 20 year event was estimated to be $20 million event. And their labor exposure to hazards was 375 hours. After fitting our solution, they invested in $63,000 in smart rollers, a Veyron gateway, and then our ongoing data subscription. And this investment yielded a payback in year 1 of half a month. And every year after, the data subscription pays itself back in a fraction of a month. Very attractive return on investment, and the reduction in risk exposure for man hours. This is avoiding your personnel being exposed to injury or risk, was 375 hours per annum. So this concludes my presentation. Thank you very much for listening to me. I would be happy to take any queries post-Congress. Thank you very much.